this is Joel, and in this video we will talk about VXLAN, BGP EVPN. It's called as connecting the dots because I actually have a couple of interesting videos on VXLAN on my channel. You can actually go down to my channel and look at this playlist called VXLAN. You'll find L2 VNI, L3 VNI, and flooding and flood and learn approach, and a lot of other related videos, right? I do get quite some good feedback on these videos, and at the same time I also get a lot of questions, right, from people in the comments. So I thought, let me make one more video where we will not concentrate much on the configuration part of it, because that's something which we have already done, and we have also talked about theory in detail, right? But what we're going to do in this one is look at it from a troubleshooting perspective, right? In order to troubleshoot VXLAN better, you would need some of those skills to look at the right things, right? So that's what we're gonna look at in this particular video, right? It's heavily inspired from the documentation over here, right? You can basically go and check it out as well. You can go down and look at the Cisco Live. There is a session, a beautiful session called Troubleshooting VXLAN BGP EVPN. So it's a very interesting session, and I believe there is also a Cisco document on troubleshooting as well, troubleshooting VXLAN. I think I don't have it here, but you can go and check it out, right? But yeah, you can, if you want, again, a double click after watching this video, you can go and check the Cisco Live documentation as well, right? There are a lot of good resources down there. That being said, coming back here, okay, so this is the topology. I think it's just coming up. I have just initiated my spine and two leaf nodes which are here, right? Pretty straightforward, right? VXLAN topology. You have the underlay, which is OSPF running here, and for the BGP EVPN, you obviously need BGP, so you have the BGP running between the leaves and the spine, and they are all working in the iBGP setup, right? And we have talked about the configurations in detail in the previous video, so you can go and check that out. And then we have two broadcast domains. One is VLAN, L2 VNI 10,000, L2 VNI 20,000, the two broadcast domains, and you can see the web devices are in broadcast domain 10,000, and the database are in broadcast domain 20,000, right? So if you want your web 1 to talk to web 2, then you can directly do it using L2 VNI. You don't really need L3 VNI because it is bridging. But if you want to talk between these two, that is, if you want the web server over here to talk to the database, then you would need to go via L3 VNI. So that's why we have the L3 VNI and the corresponding VLAN to be 99, right? Cool. So these are the corresponding L2 VNIs and L3 VNIs. I think we are straightforward with that. I think these are some of the most important things which you need when you're setting up your BGP EVPN topology, right? So that's what we have. Cool. All right. So that being said, let's go and check where we are with our topology. Give me one sec. All right. So looks like all our three devices are up. You have our spine, we have our leaf 101 and leaf 102. If you want to just look at the IP addresses, we can have a look at that. We can see that so we are basically using loopback 238 on the spine as my rendezvous point for my multicast bump traffic, right? And then we've got loopback 0 and loopback 99, which we will probably use. Like I said, loopback 99 is basically used for the underlay, right? Basically it's the L3 VNI. At the same time, we can actually have show IP interface brief. There you go. We've got this on 101 and the same thing on this one. Okay, there you go. So that's pretty straightforward. I'm not gonna go through the configurations as such because we have done that in the previous videos. Let's just, like I said, let's just talk about the working, right? And double click on that a bit. Cool. So what we're gonna do is I'm also capturing the traffic here on the Ethernet 1/1 interface. Okay, so that will help us give some idea. So I have the packet capture happening here, which is fine. Now what I'll do is let me quickly get this first host up, right? The web 1. So I'm going to do that. Let's say start. Okay. So the end host, or basically the server, is coming up and it has an IP address of 192.168.11.11. So it's going to come up in this particular VLAN, which is VLAN 10, right? So while that is happening, what we'll do is let's quickly come down to my my notes here. Let's probably write down a few things, right? Step number 1, what's going to happen? A GARP is going to be sent, right? So the end host, I just turned on this end host. So the end host is basically going to send what we call as a GARP. What is GARP? GARP is, or you call it as gratuitous ARP, right? So end host, basically when it comes up, it sends this packet to make sure no one else is using the IP address. No one else is using its IP address, right? And the packet is obviously a L2 broadcast packet it is, right? So when this packet hits my switch here, which is leaf 101, what is going to happen? Right, so when it hits the switch doesn't really know about this host yet, right? This is literally the very first packet which comes out of it. So the ARP table or the ARP suppressed cache, nothing has information on this particular host. So by default, what will a switch do? A switch would flood, right? Now in a traditional network, that flooding would be nothing but a broadcast again, right? But because we have VXLAN and because we have enabled multicast, right? In case of your VXLAN design, what we do is we set up what we call as a rendezvous point, right? So the spine here will be set up as a rendezvous point, and we can probably look at the configuration if you like. So if you go to a switch, show run section, maybe RP, there you go, right? So we have set up IP PIM rendezvous point. This is nothing but my PIM, and you can ping it and we can check. There you go. So we have connectivity to the spine, which is acting as a rendezvous point, and this is my group address, the multicast group address, right? But basically what's going to happen, the traffic when it reaches your leaf 101, it's basically going to kind of, because it's a bump traffic, right? It's a flood traffic. So it's basically going to encapsulate in VXLAN, yes, but at the same time, the packet will be destined not to a particular VTEP, rather it will be destined to a multicast address. Now, if my assumption is right, it should have completed here. So let's search for this packet. Let's search with VXLAN, and there you go, right? So we have a broadcast packet. Let's look at this GARP packet now. So like I said, this GARP packet at the end of the day is nothing but a reply packet, right? This is how a ARP reply looks as well. So this is, like I said, it is mainly generating this packet just to make sure that no one else in the network is using the same IP address. So you can see the sender MAC address is basically the web1 host, right? It is ending with 4000, and the sender IP address is again the host, and the destination IP address is the same host again. You can see 11.11, right? And it's basically very similar to your ARP reply packet, right? Now, if you look a little more in interest, this is the statement which I was making, that it is a L2 broadcast packet. It's a L2 broadcast, right? Because you can see the destination is all Fs, right? So GARP packet is generally a L2 broadcast packet. Now, when it reaches, obviously, when it reaches your the leaf, right? The leaf 101, it is, like I said, it is going to look at it, and it is going to consider it to be a bump traffic. Because it is a bump traffic, it is going to, you can see the outer IP address, destination is 238.00.10, because that's the multicast group address, right? So it's going to basically send it to that multicast address. Cool. And you can also see it is obviously putting a VXLAN encapsulation with the VNI being 10,000, because it is coming from the VLAN 10, which is in turn mapped to VNI 10,000, right? So hope that is clear, right? So we have this GARP packet which is coming in, and that has now come into the leaf 101, and the leaf 101 has, considered it to be a bump traffic, and it has gone and sent a multicast stream up, to the rest of the network. Okay, cool. So that's step number 1. Second, what happens after this? Do I have my notes here? Okay. So step number 2, we need to understand, at least from a Cisco's Nexus architecture perspective. I have talked about this before again, but there is a very interesting component which is internal to the, which is internally used, right? And it is basically called as the L2 forwarder, right? So it's a component which is used inside Nexus architecture, right? And it is the forwarding component of the switch, right? So it does everything for you. It does your MAC learning, switching, the VXLAN encapsulation, decapsulation, and so on. So this is the component which is doing that for you. Okay, so now on one side, we, like I talked about, the gratuitous ARP or the GAR packet has been initiated by the end host, right? But at the same time, when this component, this L2 forwarder component, looks at this frame which is coming in, right, the GAR packet, right, as soon as it sees this packet coming in, what it internally does is it will go and install. Basically, it does source learning, the MAC learning, right? A typical job of a switch, right, is to do MAC learning, right? And we can go and double check that. Has that happened? Let's go back to our switch. Leaf 101, we can do, this is a very interesting command if you are new to Nexus. The way you can check the MAC address is show system internal, L2, I think it's L2 forwarder, there you go, right? This is the component which I'm talking about, L2 forwarder. Right, so L2 forwarder and MAC. Okay, so what do we have here? So there you go. That's my MAC address. Right. So we have the MAC address, and we can see that the MAC learning has completed. Okay. Now next, what happens? So we have the GAR packet, and at the same time the L2 forwarder has looked at the GAR packet and it has installed this entry, or basically it has learned, right? And you can see the information, what and all it is learning, right? It is learning the interface from where it is coming from, the VLAN, right? So it is a combination of three things: MAC address, VLAN, and interface. These three are super important. Okay. Now next, the L2 forwarder component which we are talking about, it installs this MAC route into another table called as the L2 rib, right? So let's call that out. Let's write it in our notes because it will be easier for us to review it at the later part, right? So next is, this L2 forwarder then installs it into what we call as L2 rib. So L2 rib is very important because only if the MAC address or the MAC route goes into the L2 rib, only then it can be advertised, to the remote VTEP. That is in this case, what? The leaf 102, right? Only if it is going into L2 rib, only then it, via BGP EVPN, we can then send it to the remote VTEP. So that's why this step is very important. So L2 forwarder will then, right, kind of go and push that same route to L2 rib, right? So again, coming back to our show command here, I believe it is show L2, I think it's L2 route, right? There we go, L2 route, and MAC, maybe we'll do all. Okay, there we go, right? So this basically proves that same entry, this is our entry, right, ending with 4000, that's our host, that's been installed, right, into our L2 rib, right? And observe there is something called topology here, topology 10. So topology 10 basically corresponds to the VNI value, right? In our case, what is the VNI? It is, let's look at the VNI, right? Show run section VNI. So there we go. So we have VNI of 10,000, right? So VNI of 10,000 and VNI of 20,000. But the host which we enabled just now, it is mapped to VLAN 10. So we are working with which VNI? We are working with this guy, this VNI 10,000. So this topology field over here corresponds to that VNI value, or what they call it as is EVPN instance is another name for that, right? Topology is nothing but EVPN instance, and the EVPN instance for us is nothing but 10,000. So this 10 maps to that 10,000. Okay, we can also check which VLAN is mapped to which VNI. Instead of doing a show run, what we also can do is we can do, I think, show VLAN ID, and what's the VLAN we are looking at? VLAN is 10, right? And what is the VN segment it is belonging to, right? There we go, right? So it is able to tell us that VLAN 10 is mapped to the segment ID which is 10,000. This is the VNI, right? L2 VNI mainly. All right, so that's pretty interesting. So we talked about a couple of things here, right? We talked about the GARP, we talked about L2 forwarder, and we talked about L2 RIB. So now our entry or the MAC address has arrived on the L2 RIB. What happens next? So the next is we need to make sure, right? So using BGP EVPN, let's go back to our diagram. So using BGP EVPN, let's probably come here. Okay, using BGP EVPN, we have to send this. Our MAC address table is updated now because of source learning. Our L2 RIB is updated, but now we need to make sure somehow we can send the same information all the way across to the other side, which is leaf 102. Correct? We need to send it on the other side. So again, the very next activity is, again, the L2 forwarder is very important. Like I said, it is like the master, or it's basically one of the most important component in this whole exercise, right? So the L2 forwarder has gone and pushed that entry to L2 RIB. What it will do next is it will then advertise this entry from L2 RIB to where? The BGP EVPN instance, right? EVPN instance is nothing but what? Your 1000, 2000 and so on, right? In our case, we have just enabled one host, or we have connected only one host for now, so that's why we are talking only about 10,000, right? So that's the very next step. So let's see if that has completed. How do we check that, right? So for that, we will have to do show L2 route EVPN, and I believe MAC. Let's put a question mark. See, there are two types of routes, MAC and MAC IP. I'll talk about that in a minute later, but we are talking about the MAC now, which is the MAC address, the ending with 4000, right? MAC, and what is the next? EVI. See, this is exactly what I was talking about. EVI is nothing but the EVPN identifier, right? EVPN identifier or EVPN instance ID, whatever, right? And what's the instance ID? We talked here, it is 10. So that's the one which is mapping to it. So I'm going to put 10 here, and there you go, right? Pretty similar to the output which we saw earlier, but just want to show you that that same entry from the L2 RIB, right? It has now arrived on my BGP EVPN instance, and you can see the MAC address is here, the interface is here, the topology or the EVI value is also there. Cool. Now next, what happens? So we are on the EVPN instance. Now the next is this entry, because what is our final goal? We have to somehow send it to the other side, right? Now before sending it to the other side, we have sent it, or we have leaked this entry into BGP EVPN instance. But from there, it has to next go to what we call as BGP EVPN address family, right? Address family instance or address family, right? What do I actually mean by that? If I go and do show run section router, right? There you go, router BGP is here, and where is my address family? This is the address family, right? So we from the EVPN instance, we have to now send it to the address family, right? Only then it will basically be sent, as a using the whole route distinguisher and route target, because at the end of the day, what is the whole process we are using here? We are using nothing but like MPBGP, right? So we have to send it to the other side, to the other VTEP. So the last step is basically on locally from the EVPN instance process, I need to leak it into this address family, right? Because if you look at router BGP, right, you can have different kinds of address families, correct? IPv4, IPv6, you can have things like VPN v4, VPN v6, so you can have different types of address families. So we need to make sure, right, we are leaking into the correct address family, and that's what we are basically doing here, right? And how do we check that? So again, let's do that. Show BGP L2 Vpn EVPN, right? And let's put the VNI ID this time, which is 10,000, right? There we go. Cool. So what do we see? Is this correct? Yes, it is, right? So we have, you can see here, there's something called /216/272. Don't worry about this /272. This is that MAC plus IP route, whereas this is the MAC route. We'll talk about MAC plus IP later, but we are mainly concentrating on the MAC route for now. And you can see this is the MAC address we are talking about, right? Ending with 4000, that's my host. Okay. So, and then observe here the L2 VNI is also displayed here, which is 10,000, right? So that's perfect. So what has happened? We have come into the address family successfully. We have come into the correct address family, which is nothing but L2 VPN address family, and inside that it is the EVPN instance ID is also correctly attached to it, which is 10,000. It's not in the wrong instance ID, it is in the correct one. Okay. Now we need to see if this is happening, right? I mean, if you want to actually go and check if this MAC route is actually getting installed, right, into the RIB, basically before going to the RIB, it will have to go to the BGP table, right? So if you actually want to check that, you can look at the events maybe. So show BGP internal, probably events history, I guess. Yeah, events history, events, and then you can pipe it with your MAC address. In my case, it's this one. So you'll basically end up seeing a lot of these events, and if you drill through this event somewhere, you will basically see, like for example, you'll see added a new prefix or something like that, right? So you will see installing a prefix or adding prefix and so on. You'll have to dig through this a little bit into the RIB table and into the BRIB table and so on. So yeah, but that's just for your information. If you want to actually see because those events also gets logged internally, so you can actually see if that MAC route is getting installed inside the BGP table, and finally ultimately from BGP table, where does it go? To the RIB, right? Because whatever is there in RIB then gets programmed on the line card, and it gets programmed on the ASIC, and the forwarding happens and so on. That's a traditional how routing switching works, right? But anyway, so we have talked about this. Let's probably quickly recap where we are, right? We started with the GARP packet, then we talked about this important component called L2 forwarder. When we talk about, again, we are mainly concentrating on the MAC address for now, or the MAC route, and so basically, yeah, so after the GARP, the source learning would have happened on the Leaf 101, and this L2 forwarder is the one which will make sure that the source learning happens. Once that happens, it will install the entry to L2 RIB. From there, the entry is then sent to BGP EVPN's instance, right? The specific instance, in our case, it is L2 VNI 10,000, and from there it is going to the address family. And from the address family, it basically the route is created and the routing updates are basically sent. Okay, so we can actually see these routing updates. Let's come here. So maybe if you want, I could probably, it's actually not a separate step. In fact, in this particular step, right, we are basically gonna get routing updates here, right? So routing updates are basically sent over there. But let's look at this routing updates. I believe we can see those. So what we can do is, let's see. So we will do something like show BGP. Let's actually do a term length 0 because it might be big. Show BGP L2 Vpn EVPN, and we'll have to put in this MAC address. This is the MAC address. Let's put that guy, and I think that should be fine. Okay, there we go, right? So it is showing us the routing updates here. Few things right off the bat. On the top, we have something called as route distinguisher. Route distinguisher is a common topic, right? When we talk about MPBGP, route distinguisher is very important because it allows multiple customers to kind of, or multiple customers to kind of use the same prefix, in a whole VRF environment, right? So that's exactly the same logic here as well. So we have the route distinguisher, but very important here is, so important part here is how did we arrive at here? That again depends on the configuration. So in my case, if I do show run, did I type somewhere else? Let me see. Okay, I lost my console. Give me a second. Or is it back? Okay, it's back. Okay, show run section EVPN. Okay, so you see in my case I have put RD as auto, right? So it is auto picking this route distinguisher. How is it doing it? The formula is, let me actually write it down here. So for, okay, let me grab my pen. Okay, so we are talking about L2 VNI, right? And in this case, the RD, right, the route distinguisher is obtained using the BGP ID, right? So the BGP ID plus, or it's nothing but I think it's colon. It uses the colon, and then there is a number. I believe it is 32767 32767 plus the VLAN ID, right? So let's confirm if that logic is true, right? So let's come back here. So if you look at the it's nothing but 192.168. This is the BGP ID. VLAN number is 10. So if you add that 32767 plus 10, that's the correct one, right? So that's the route distinguisher. So remember when I was talking about in my L2 VNI session, right? I think even in my L3 VNI session, I kept on repeating something called as MAC VRF, right? Now, this is the reason why we were talking about, something like MAC VRF, right? So, yeah, the reason is because, VRF, when you talk about VRF, right, you're going to have route distinguisher and you're going to have route targets, right? And that's your traditional IP VRF. But if you look here, this is our route technically, right? And if you look at this route, right, this is actually a MAC route. There is no IP address here at all, right? But because it's a MAC route and it has a route distinguisher and a route target, which will be over here, right? So that's why we were referring it as a MAC VRF, right? So if you look at the big picture, VXLAN EVPN or BGP EVPN scenario, right, you're basically going to have inside one tenant, right, very similar to the diagram which we have here, or the topology, right? So we are going to have each of these L2 VNIs in its own VRF, right? So each of this, you're gonna have a MAC VRF for L2 VNI 10,000, other one for 20,000, and you will also have a L3 VRF with 10099, right? So that's why we kept on referring, because that's what the whole EVPN address family is all about, right? It is able to kind of transport the MAC routes from one VTEP to the other, right, using BGP, but at the same time it is also giving you this cool features of BGP, which is nothing but the route distinguisher, right, which is allowing you to distinguish the routes from VLAN 10 to VLAN 20. That is why you see the formula for route distinguisher is BGP ID plus colon this number, which is 32767 plus the variable, right? So if the VLAN is 10, then it's going to be 32777, right? Otherwise it will be 32787, right, if the VLAN is 20. So based on the VLAN, the route distinguisher will go on changing, right? Cool. So that being said, let's come back. What we are looking at. So one thing we looked at is the route distinguisher. I want you to remember that. So that formula is going to be different when we talk about L3 VNI later, right? For L2 VNI, this is the formula, and keep that in mind. And now let's look at the routes per se, right? Like I said, we have two important routes here. One route ends with /216, other one ends with 272, right? /272. So that's nothing but bit count, right? It's nothing but the bit count of the prefix. So 216 is the bit count for MAC only advertisements. This is just a MAC route. So you need to remember that. And then, you need to remember that the most prominent routes which we will talk about, at least in this video, will be mainly type 2 routes. So EVPN has different types of routes, and type 2 are the most prominent ones, at least in this video. Type 5 is the other prominent one, where you have multiple VRFs and all of that coming into play. But you can see here everything starts with 2, right? So these are type 2 routes. Now even in type 2 routes, we have again two types in that, right? One is the MAC only route, which is this one, and the other one is the second one, which is here below. It's a bigger in size. You can see it's 272, and this is MAC plus IP route, right? So we have two different routes. So hope that is clear, right? Now, again, let's not talk about this one yet. We'll talk about this guy later, the MAC plus IP route. We'll talk mainly about this MAC route, right? So when you talk about this MAC route, you can see, like I said, route target. It has route target, which is nothing but the route target is obtained by, again, the AS number, right? BGP AS number, which is 65,000, colon the L2 VNI, which is 10,000. So that's how you come across the route target. You can manually define this in the configuration, but I have kept it to be auto, so that is why the switch itself is generating that. Right, there is another extended community which is encap 8, which is nothing but the encapsulation type of VXLAN. Right, so this information will also be sent in the BGP update. Okay, and like I said, this second part we'll discuss later. But yeah, so you just need to know that that is bigger in size. So 272 and 216. How did you come across this 216? It's nothing but adding all of this, right? The bit count, right? So here it will be what? 32 bit plus probably this is 1 byte, maybe 8 bit, right? So you keep on adding. This is 48 bits. So you keep on adding from all the way so much, you will basically end up getting 216. Okay, cool. So like we talked about, so this is what I showed you here. But let's see now on our capture, are we able to see that route? So let's see, BGP, enter, and let's see, we should see something called update. Okay, there we go. We have something called update. So let's look at probably one of this update, right? Probably let's look at the second one. Okay, there we go, this one, right? So let's look at this update. What is this update? So this is the MAC only update I was talking to you about, right? So let's see, I mean, it says it's a BGP update message. In the path attributes, let's come here, and there you go, extended communities. Let's click on this. There are two extended communities. There you go, 65,000 and 10,000. This is the route target, and you can see the other is the encapsulation type. We talked about this, right? So that is sent as the community values. Then we'll come to the actual, network information which is sent to the other side, right, via BGP. So that's what this is about. And here we will look at probably this guy, right, the EVPN LRI information, and you can see here it says IP address is not included because we are talking about only MAC only route. There's one more route that will be the second other update message, right? And in that update message we will be sending both MAC and IP information. So in this one we send it only for the bridging scenario, right, where we want two hosts in the same VLAN to be able, or same VNI to be able to talk to each other. So that's why we are just sending the MAC information here. Okay, so that's how it looks, right? That's how the packet looks. There is also like next hop here somewhere, I think over here, yeah. So you can see the next hop information 192.168.100.101 is also sent out. So what have we achieved now, right? Let's come back here. Let's quickly revise. So we have done all of this. The L2 forwarder pushed the data to L2 RIP. Then it has gone to the instance ID. Then it went to the address family, and from there, the routing update was sent, right? We talked about this route, how the route distinguisher looks like, and we also talked about the route target as well, how the route target looks like when you talk about L2 VNI, right? Cool. So all of that happened. Now the update has come on the other side, which is the destination or the remote host, the remote VTEP, which is leaf 102. So let's go and look what has happened over there. So let's come to leaf 102, which is here. Let's log in. Okay, so we are on leaf 102, and here what I'll do is I'll do show BGP. Again, I mean, here we'll have to do the reverse, right? So we have to go from bottom to top because we have received the update. First we have to check if everything is good in the address family. Then we have to check if everything is good in the instance, EVPN instance, and then the L2 RIP, right? And then we have to finally check the MAC address table, right? Because that will be populated by the L2 forwarder, right? In this case, so yeah, we have to basically do the reverse. So let's do that. We are checking on the remote one now. So to show BGP, this one is exactly same command what we ran here. So let's do this. Let's grab this guy. This was the last command which we ran here. So we are going to do that as the first command in my leaf 102. Okay, let's do a term length 0. There we go, right? So what do we see? First, let's see, do we see our routes? See, we have a /2 what is that? 272 route, right? This is that IP plus MAC route is visible. and the other one is okay, I think it's here, okay, /272, and the other one is /216, right, inside the L2 VNI, right, because this is one this is one update, this is coming as a part of the second update, right. But anyway, so both the information is available here. So we have received both of these. You can also double confirm the route target values which we talked about. Let's scroll a little bit top, maybe. I don't know, where did we go? I think it's here. Okay, so let's, okay, so L2 VNI, if you look at which is the first route, so this is the first route, which is just the 216 route, which is the MAC route. You can see the route target is very same as what we saw earlier, right? It's 65,000. And whereas when we talk about the IP plus MAC route, it will have two route targets. One is the route target for the L2 VNI, right? Another one will be the route target for the L3 VNI. So that, I mean, this is the route target of the VRF itself, right? To get imported in the VRF, because this update has both IP address as well as MAC address, and that's why it is bigger in size as well. It's 272. Okay, cool. But anyway, so I mean, what did we note from here? We are sure that both the routes have come or arrived on the second VTEP, and they have installed, you know, they have been installed in the correct VNI also, which is VNI 10,000, right? We are talking about just L2 VNI here, not the L3 part. Yes, L3 is also visible, but we'll talk about L3 later. But anyway, so we have installed everything in the correct L2 VNI. Now, what would that mean, right? How did it get installed in this correct VNI? Because of the route targets, correct? Because it had the correct route target of 65,000, 10,000, right? Because of that, it got installed in the correct VNI on the destination VTEP, right? So that's the reason. Anyway, so once that is done, the next is obviously we need to check if this I mean, obviously this is also installed. Like I said, this one we'll talk about later. So let's probably look at let's also look at the whole BGP table, right? Instead of looking at just only one MAC address, let's probably dump the whole BGP table with respect to EVPN. And here you can see that you have the L2 VNI. This is what we are talking about, right? This is a little concise and a better view instead of looking at a very cluttered view on the top. Here it's a very it gives a summary where you have, this is what we are of interest, right? Whereas this one is also installed, the 272 one, which we talked about earlier. Okay, all right, so that's good. Then so once this is that, let's then so we know that the address family is all good. Let's then check if the MAC address is basically present in the EVPN instance, right? So EVPN instance, because that is how we are, going in the reverse direction. So this is all good. Now we are going to check in the EVPN instance, right? If that process has received this MAC address, right? So we'll do show L2 route, and we'll do probably EVPN MAC and the ID, the topology ID or the EVPN ID, which is 10, right, for our VNI, and you can see it is installed. But the fun thing is, see here, it says it is produced by BGP, whereas if you run the same command on the other side, which is on the originator, you would see it is produced local, because it is local to this VTEP, right? Whereas on the other side, it has understood, or it has learned this particular MAC address, right, or the MAC route via BGP. So that's why it is telling produced by BGP. Okay, so that's good. So we have verified that it has come into the EVPN instance. Next, from the EVPN instance, it has to be copied to the L2 RIB, right? So let's do that. Show L2 route, MAC topology, and the value is 10, right? There you go. So here also it clearly calls out that we have learned this from BGP EVPN, right? And it is available here also. From the L2 RIB, the only last thing which we need to check is the MAC table, right? We need to double check if the MAC table has it. So how do we check the MAC table? Show system internal for L2 forwarder and MAC, right? You do that and you can see this is the entry, right? So we have learned it from the NVPR, right? So that is looking good. So we actually looked at the whole end-to-end process, right? So we started with, just to summarize, we started with the end host. We connected the end host, it generated the GARP. From the GARP, the local VTEP, basically using this process L2 forwarder, which is inside the switch, it learned the MAC address using source learning, right? And then it installed it inside the MAC table. It's on MAC table, right? And then from there, we actually, again, the same process, went and installed that entry into the L2 rib, right? Because this is needed. Anything you want to advertise into BGP, it needs to be part of either L2 rib or L3 rib, right? We'll talk about L3 rib in the next section, but we did L2 rib for now because we just wanted to exchange MAC route. Then we have BGP EVPN, from once it comes into L2 rib, then it went inside the EVPN instance process, and from there it was leaked to the address family because of the configuration. And from here, 2 routing updates went, one for MAC only advertisement, other one went for what? MAC plus IP. And we did the same process on the other side as well. We came from 5, 4, 3, 2, 1, right? We verified on the remote VTEP. So that's how the whole workflow goes through, and we talk about the control plane of the BGP VPN, right? Now, like I said, we talked only about the MAC route, right? Now the same thing we're going to talk about. What? We're going to talk about the MAC IP route, the second route. Okay. So we'll talk about second route again. What would have happened? This is still there. Let me use a different color, right? So the GARP has already happened, right? I can't again do the GARP because GARP has already happened from the end host, which means my my local VTEP, right, which is this guy, right, the leaf 101, it has learned what? Both the MAC address and the IP address, right? Because of so it would have learned both the MAC address and the IP address from that packet, right? So we can now check the ARP table on the local VTEP and see what it is telling us, right? So let's go to VTEP 101 and let's do something like show IP ARP, I guess. So IP ARP, maybe let's put VRF, and my VRF is bits please. There we go, right? So it is giving us information that, look, this is the address 11.11, this is your MAC address. So in the R and the VLAN as well, right? And the other important piece is it would have also done this, or it would have actually, let me actually mention it here. It's good to kind of call that out. So there's another important piece, which is one is your ARP table, and there's one more table called as ARP suppression table. What is the use of this? So ARP suppression table is actually a very super cool feature, right? Actually, let's look at the ARP suppression table. So from the ARP table, then the entry would have found its way into the ARP suppression table as well. So we'll do show IP ARP suppression cache, right? Detail. Okay, there we go. So it has come in here as well. Now, what's the use of this ARP cache? Now, because this guy because this particular entry is present in the cache, if the switch or if the switch receives any ARP request for this particular IP address, it doesn't have to kind of send it all the way across the fabric, right? Doesn't have to flood it anymore. It can answer, or it can proxy those ARP requests directly, right? So yeah, so that's the reason, right? The same thing, the ARP cache is populated here, and because we earlier sent a multicast BUM, right, we sent a multicast traffic or stream throughout the fabric, the leaf 2 also received that multicast traffic, right, and it also did source learning, right? It also kind of looked at the packet and it was able to understand that this is the IP address and MAC address, so it has also learned, so that information will also be present on the leaf 102. Now, how is this really helping? In future, if any of the end host wants to talk to web 1, a new ARP request is going to be generated by that particular end host, but that need not be sent all the way across the fabric. Rather, this leaf can answer it by himself, right? Because it is present in the suppression cache, right? So that's important. And where does that configuration actually go? It will go under the NVE, show run section. If you see NVE, you will see that for each of the member we have suppressed ARP. Okay. Now, like I said, the same thing, this suppression cache should be available on the other side as well, which is leaf 102. There you go, right? It is available here as well, because like I said, when that multicast packet was initially flooded, right? I mean, when I say flooded, I mean to say it was sent to the multicast group, right, by the VXLAN VTEP on the leaf 101. So that time leaf 102 got that packet and learned it, right, and it populated the separation cache. So that's important. So that's good. Okay, so we have that. So we have the IP, we have the MAC, we have it in the ARP table, we have it in the ARP separation table as well. Now next is obviously, so what was the next step when we did this MAC routes? We talked about this L2 forwarder, right? But in case of when we do the MAC IP route, the component which is of interest is what we call as HMM, host mobility manager, right? So just like this L2 forwarder was taking that MAC route and putting it into L2 rib, here in case of my MAC IP route, this host mobility manager is the component which is going to, right, take the entry, right, take this MAC IP route, and it is going to populate it into the L2 rib and the L3 rib, right? And we can actually look at that. We can actually look at that using a show command. We can do show fabric forwarding, right? IP local host database VRF gets place. Okay, so you can see here it says HMM, right? HMM host IPv4 routing table, and you can see this is the entry, and the HMM has actually taken that entry and added it to the L2 rib, right? We can also see the detail of this command, I guess. Let's see, can we? Am I stuck again? Alright, so I'm back. Okay, so we are looking at the HMM. So we can also probably, what we can do is we can put the same command and we can actually look at the detail as well. So we can, let's go to this particular host, and there you go, right? So we can get the detailed view of this particular host, and we get that information that this particular HMM is the component that has actually added this entry to both L2 rib and L3 rib, right? And you can see the IP address, you can see the MAC address, and the interface and so on. Okay, so once that is done, let's use the similar command which we did, right? Just like our L2 forwarder earlier was then sending that entry, right, from the L2 rib, it was sending it to where? It was sending it to the EVPN, right? Let's go back here. So in case of my L2 forwarder, HMM has done the job. So the entry has come into L2 rib and inside L3 rib. Okay, now but from here, okay, why it has come inside L3 rib? Because in this case I have IP address as well. It's not just MAC address, right? It's MAC plus IP. That's the second route. Anyway, so it has come in here. So once it is there, the next is the same thing, right? It has to go inside the EVPN instance. Only then I can send that particular route to the other side. So we'll check that now. So for the EVPN instance, what we can do is show L2 route. Always remember, when you're checking the L2 rib, it's always show L2 route, right? So L2 route EVPN MAC-IP this time. Let's use MAC-IP because that's the route we are interested with. And the EVI value, right? EVPN instance 10. You can also do detail, right? There you go. This gives us information. So this is telling, look, this was produced by HMM. This was not produced by L2 forwarder, right? This entry in my EVPN instance ID table was produced by HMM, and that's the entry, that's the MAC address, that's the IP address, and it is also telling that, look, now we are ready to send it to BGP, right? So we are ready to send it to BGP. So L2 rib is all good, and because of L2 rib is good, from L2 rib it is going to BGP, right? The L3 rib is also good because it is obviously appearing in the routing table, which means that it has come to the L3 rib. What we can do is we can do show IP route VRF bits please. Maybe we can do a section with the same IP address. that kind of proves that it has come to the L3 lib as well. There you go, right? So both L2 lib and L3 lib are good, and from here we need to now next check, right, that if the information, because the information has to be sent to the remote VTEP, right, that is leaf 102, it has to be sent from these two tables. It has to be then sent to the BGP address family, right? From the instance, it has to be sent to the address family. So we can check that. So we'll do something like show BGP L2 Vpn. This is exactly the same command as previous, but instead, you know, I mean, we did the same command when we did the MAC route. Instead of putting the MAC address, let's put the IP address this time. Okay. We can also put the VRF because that's important. There we go. So that's what we have, right? All right, right? So that looks good. What is of interest for us here? Maybe the route target, right? Look at the route target. So because this is, and look at the route, it is /272 route, right? This goes back to what I was talking earlier, correct? And because it is under L2 VNI, correct, it's under the correct L2 VNI, right? Because we are talking about 10,000 right now, so it's under the correct L2 VNI. The route distinguisher is also pretty much the same, right? Because it's again L2 VNI is route distinguisher, right? So that's good. And let's look at the route. The route itself is /272. That's the route. It's still type 2 route, and the route target is, it has two route targets because it has to be, because this is MAC plus IP route, it will be imported into two VRFs. One will be the MAC VRF, and also it will be imported into the what? The L3 VRF, which is corresponding to this route target, because 10099 is nothing but the L3 VNI, right? So that makes sense. Right, this is the route target of L3 VNI, this is the route target of L2 VNI. So that's why it has both. If you go back to my previous example where we are talking about MAC route, it just had only one route target because it has to be imported only to the MAC VRF. But this one has to be imported both the places. So because we have IP address with it, right? Cool. So that's good. So we have now seen that the route has successfully gone to my BGP address family process. Now let's do the same thing like we did earlier. Let's do the reverse from the remote VTEP, that is 102, right? Which means we will have to run the same command which we ran here. Let's run it here. Let's see what's happening. So there you go. That's the whole entry which we have, right? So like I said, we are basically going to have two updates coming in, right? So the two updates. So which are the two updates? One is this one, the slash. Okay, give me one sec. Is it slash? Okay, so because we are already looking at the IP address here, it is just showing us the /272, right? All right. So the remote VTEP, which is 102, has received the correct BGP EVPN update, right? So it has received. You can see the correct L3 VNI values. One is 10,000, other one is 10,099, right? So it has imported, and you can see this particular route is basically the there are basically two, it's getting imported over here as well as it is getting imported to L3 VNI over here because of the route targets, right? It has the correct route targets. So this one thing here, the route distinguisher when we talk about L3 VNI is different, right? It is nothing but the BGP ID and colon the I think this is the VRF ID if I'm not wrong. If I do show VRF, there you go, the VRF ID is 3, right? So it basically gets it from there. So basically going back to my discussion here, this logic, or basically this particular formula is valid only for L2. For L3 it is different. For L3 it is nothing but BGP ID colon VRF ID, right? That's going to be the route distinguisher, right? And the route target will still be nothing but AS number in the L3 VNI value, right? So that is pretty much still the same, because you can see here it's nothing but 65,1099. Okay, cool. We can quickly have a look at the packet capture as well for this one. So if you look at the other update package, you will see that here you go, right? The route target in this one, it is carrying 2 route targets, unlike the previous one, right? It has this 65,000 10,000 and 65,000 10,099, right? One corresponding to L2 and the other one corresponding to L3 VNI, right? And if I come to the NLRI information, you can see it is also having IP address, right? Because this is the MAC, it has MAC information as well as the so you can see the MAC information here, it has the IP address. So it's a MAC plus IP route, right? So that's why it is sent as a second update, right? So we are all good with that, right? So it has come and we are happy with it. It has come to the address family. Now what we can do is we can also go and check if it has come to the correct EVPN instance ID, right? So show L2 route, EVPN, MAC IP, and EVI, and the value being 10 detail, right? There you go. So it has come inside the correct EVPN instance, right? And here it is telling send to ARP. It means that it has learned it from BGP. It has come inside the EVPN instance ID. Now it has to leak it to the VRF. Now if you do directly show IP VRF in the so show IP ARP and the VRF, you will not get anything. See, if you do this, you will not get anything. You will not find that entry. But if you really want to find, you will have to do the separation table. So it would have leaked it to the separation table. Show IP ARP separation cache, right? It's separation cache detail. There you go, right? So the entry has come down here. So we saw how the whole thing works, I mean from end to end, right? So if I have to summarize this, at least the MAC IP learning part, what really happened was we learned that the remote VTEP, which is 102 in this case, it received 2 updates, 2 BGP updates. One update was just the MAC only update, which we talked earlier, right? And that had just one route target, which is 65,000 10,000, right? And that got imported into all your earlier tables, right, which we talked about here. So it got imported into the L2 RIP table, it got imported finally to the MAC table and so on. And that is mainly used only for everything here in red. It is basically used only for bridging, that is if you want to talk between web 1 and web 2. But the second update which we have in here in blue, right, that's the MAC and IP BGP update, that had 2 route targets, right? One route target was meant for the L2 VNI, right, whereas the second route target was meant for the L3 VNI, right? We had it as 65,000 colon 1000, no sorry 10,000, other one was 65,000 colon 10,099. So 2 route targets. The first route target was again doing the job of getting imported into the, if you go a bit top here, you can see the first route target, which is 65,000 10,000, is doing the job of, because of that route target, that particular route is getting imported into the L2 VNI, right? So that's why we see that /272 route under the L2 VNI, because you have this, this route has both ARP, this route has both MAC address as well as IP address, and the main job of this particular entry or this particular route, why we have it, is to kind of help with the ARP, right? To mainly help with the ARP process, right? Whereas the second entry, which is just the IP address, right? Just the, the whole route gets imported, but my L3 VNI, if you see, it is nothing but corresponding to the VRF, right? So in my VRF, what is of very importance to me is nothing but routing. So this entry which is coming inside the L3 VNI, right? It first of all, it is coming inside L3 VNI because of the presence of this route target, right? Because we had 2 route targets, so because of the presence of this route target, it is coming inside the correct L3 VNI, which in turn corresponds to the VRF. In my case, it's called bits please. And the job of this entry is to route the packets, between the 2 subnets, or between the 2, inside the VRF, but between the 2 broadcast domains. So if I want a packet going from web to database or from dead to web, database to web, then the packet will have to traverse this as part of that symmetric IRB and all of that, which we talked in the previous video, right? But yeah, that's the job. That's the job of these two updates. Just to recap, two updates. One is MAC only update, another one is the MAC IP update. MAC only update gets imported, into basically it's just the MAC address, so it gets imported into all the MAC table, L2 RIP table, and all of that. Whereas MAC IP, right, this particular update gets imported both into the L2 VNI as well as L3 VNI. In the L2 VNI, it gets imported because we can then use it for ARP suppression, right? That way we can kind of reduce the ARP flooding throughout the fabric. Whereas it gets imported into the L3 VNI, and at the end of the day, L3 RIB, or the routing table of the VRF, because we want that route if we want to kind of route the packet between the two broadcast domains. Okay, so hope that is clear. So now I think we are in a good place to start the testing, right, which is kind of look at the data plane side of things, which we have actually looked at it before, but we can look at it again, right? So for that, what I'll do is let's probably quickly get this other guy up. So we are gonna first probably get the web 2 up. So let's give it a few seconds, right? There we go. Looks like my second client has come up. That's why when I did the show IP ARP suppression cache on the host number, or basically leaf 101, I can see it, right? 11.11 and 11.12, both of them are visible here. Whereas this is learned locally, this is learned via what? Remote adjacency. So it is learned from this guy, from the other VTEP, right? So that means if I do a ping now, right, the first packet probably, okay, so I should not do a ping from here, my bad. So let's do a ping from the host, right? Let's go to web 1. It's nothing but a router for me, but anyway, let's do a ping to what? Let's do a ping to this guy, 11.12, which is, I'm trying to do a ping within the same broadcast domain, right? So it is going to do a bridge. Now the first packet, maybe 1-2 packets might be lost because of ARP. Well, that's fine. There you go, 1 packet is lost. Okay, 2 packets got lost because of ARP, right? But at the same time, the ARP packet probably wasn't sent all across the fabric because of ARP suppression cache, right? And if you come here and look at the ping packet, let's come down to the bottom. We're looking at BGP, my bad. Let's remove that. Let's remove the filter and let's look at let's come down. There you go, right? We have the ping packet. So if you pick one of the packet, you will see that this is the packet going from 11.12 to 11.12 to 11.11. Okay, that's okay. Probably I did a ping from the other way around, is it? Maybe, okay, or maybe I did a ping to 11.12 source. Okay, that was a reply, my bad, sorry, that was a reply. So if you look at one of the packet here, which is coming from 11.11 to 11.12, you can see it is going via VXLAN, and you can see it is having the correct VNI, right? Because it is L2 VNI, because we are talking within the broadcast domain of VNI 10,000. Okay, now let me get the other 2 guys up as well. So let's get these 2 guys, which is nothing but the database servers, and they are in a different broadcast domain, right? They are in 192.168, 12.11 and 12.12. So let's wait for a couple of seconds. Okay, that was quick. So I just ran the ARP table again, or the suppression cache, right? And you can see all the 4 hosts are visible here, 11.11, 11.12, 12.11 and 12.12, right? So all the 4 hosts are available here. And this time, if I do a ping between what? If I do a ping from web to database, right? So let's do that. So instead of doing 192.168.11.12, let's do 12.12. So that will be talking to the database on the other switch again, right? So this time actually, I think the ARP kind of completed even before the first packet was lost. So you see all the packets went through. And this time if you go and check the encapsulation, you can see the VNI value which is used is 10099, which is L3 VNI, right? The L3 VNI is used because we are talking between 2 broadcast domains. We are not talking within the broadcast domain. We are talking between the 2 broadcast domain, and that is the main use of that MAC IP route, right? We learned that MAC IP route and as a result, because of that MAC IP route, we were able to learn the IP address into the L3 VNI, and as a result, when the packet hit the leaf 101, it was able to route it out into the correct via the VRF using the information it has learned from the L3 VNI, and it was able to route it out and attach this correct label and send it across. Right? So yeah, that's mainly it, guys. Just wanted to kind of give you a glimpse of how this whole thing works. I think some of those doubts which you guys probably had, some of the questions which you guys posted in the comments, I think those are clear now. I mean, when we talked initially about the BGP EVPN, we used some of the terms like MAC VRF and all of that, but I think with this, I think it's a bit clear, right? So do check this out, do try the same thing. Go, if you want a little more deeper information, go down and check out the Cisco Live presentations as well as certain Cisco documents on troubleshooting VXLAN, which will be helpful. And hope it was useful. Thanks a lot for watching, guys, and have a good day. Bye.